let's start. So last time we played the game. I hope you guys enjoyed it. So the reason we played it multiple times. Who can tell me why I want to play it multiple times?
We kind of get a sense of everybody else's prices and
Because I want each group form that kind of expectation for the other group. Okay? Actually, as if we played a couple more times, all your decisions will be very, very similar. The output you're gonna choose is going to be very similar. And also that output you're gonna choose is going to be very close to the equilibrium output. Okay? So that's what I'm trying to get there. Okay, so now, since you guys played really well, and let's solve it mathematically. See what is equilibrium output is. Okay, see how close. So we have 3 companies instead of 2 now, okay? And the information we have from the market is P equal to 45 minus 0.2 Q. And Q here is equal to Q1 plus Q2. This is information in market. Then we have the firm's profit is equal to P price multiplies the marginal cost and the average cost and multiply QI. Okay. So this F5 here is the marginal cost and also average cost. Okay, so now how do we solve? This is a Coulomb oligopoly, which means all of the company, all the group make the decision simultaneously, right? Okay, so it's a simultaneous move. And as for the Coulomb oligopoly, how are we going to approach the problem mathematically? Where we're gonna start from? So where will we start from? What each firm is trying to do? What each one of you was trying to do yesterday, last week? Minus the profit. Okay. So how each firm maximize the profit? Mathematically. Louder so everybody can hear it. Marginal revenue equal to marginal cost. Profit maximizing condition, right? We already start from there. Okay. Do I have marginal cost information?
yeah,
Yes. What is it? Marginal cost?
5.
Okay. We need to find the marginal revenue. How do we find marginal revenue for each firm?
P times Q.
We need to find the total revenue for each firm, right? What is total revenue for each firm? Price multiply the quantity of that firm minus what?
Cost.
You have it here already. Already given to you, right? That's the profit, okay? Minus 5QI. Alright, so let's just say, we start with group 1. So I change this I into 1. So total revenue for group 1 is equal to P multiply Q1 minus 5 and 5QI. Question?
What does the I stand for?
I could be 1, could be 2, could be 3.
Okay.
So I just generalize,
Okay.
Okay, everybody's following me here? Okay, so now what's next?
Marginal revenue.
Can you derive the marginal revenue right now, or you have to have other steps before to do
Well,
it?
you gotta
P have to
multiply them.
Yeah, the P.
You have to replace P, right?
Yeah.
Okay, so replace P with that.
So
Okay.
45 minus 92.
So it's 45 minus 0.2 Q multiply Q1 minus 5 Q1, right?
Mm-hmm.
Okay, what else do we need to do here? There is a Q1 here, but there's this Q here. What do we do with it?
Distribute it.
We're going to use Q1 plus Q2 plus Q3 to replace that, right? You guys remember that?
Mm-hmm.
So then we have 0.2 Q1 minus 0.2 Q2 minus 0.2 Q3 multiply Q1 minus 5 Q1. How about if I have 4 firms? You just have all of them line up, right?
Mm-hmm.
Guys get it? Follow me here, everybody? Okay. So next step here, you're gonna open the bracket here, then you have 45 Q1 minus 0.2 Q1 squared minus 0.2 Q2 Q1 minus 0.2 Q3 Q1 minus 5 Q11.
Right.
Yeah.
Why you were smiling or laughing?
Cause you just did that all in one notion. It was just amazing.
Huh?
That whole Q sequence, you just did all that in one notion. It was just funny.
Okay, so 45 Q1 is here, 5 Q1 is right here, so 45 minus 5 will be 40, so we just have 40 Q1 minus 0.2 Q1 squared minus 0.2 Q2 Q1 minus 0.2 Q3 Q1. Okay, so now what we have is the total revenue expression for the first firm, right? Okay, the next step, guys. Don't lost in that expression, okay? Don't worry about it. Okay, what's the next step? What is next step? What's the next step? Why do we derive the total revenue?
So you can find the margin.
So you can find the marginal revenue,
So how do we find the marginal revenue from the total revenue?
derivative.
Good, so you know that, right? Okay. So you take the derivative of this whole thing with respect to what?
And
To
Q1.
No, don't know. I'm asking him.
Q,
With respect to which variable?
Q1.
One. Okay. So you take the derivative. Okay. So now let's take the derivative of this whole thing with respect to Q1. Okay. From the first term, what do we got here? Nehemiah. Now remember your name very well. Okay. What's the derivative of this with respect to Q1?
40.
Okay. All right. The second one, Brandon. What's the derivative of the second one?
I get, wow. What's 2 times 0.2? 0.4. Thank you.
0.4 and
Q1.
good. Okay. Robert, the third one. What's the derivative of this with respect to Q1?
Wouldn't it just be Q? Wouldn't it just be Q? Or
You're taking the derivative of this with respect to Q1. So you treat the
point 2?
Huh?
Point 2?
it's 0.2.
Q2.
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 Now you treat the Q2 as a constant number, remember? when you take the derivative with respect to one variable, all the other variables are like constant numbers. Okay, so you have to copy this down as well. Okay? Okay. So how about the last term? I forgot your name. What's your name?
Justin.
Justin. Okay, just Justin. What's the last derivative of this one with respect to Q1?
Is that a 3?
What?
Would be 0.2
Q3.
Q3.
Okay, so this is the marginal revenue for Form 1. Okay. Now we set this equal to what? 5, right?
Mhm.
Okay, set this equal to 5, then we're going to find what? Then we solve this, solve Q1, right? We're gonna solve Q1, so go ahead and solve this Q1. Do this practice because for this coming homework, remember you have to give me the steps, and that's what I'm expecting you to do. You know, and you write down the steps of each problem. That's what you do. Yeah. So work on this. So what is Q1 equal to now? 40 minus 5 would be 35.
30.
Then you gotta divide it by 0.4.
That is equal to 35 divided by 0.4.
87.5.
Huh?
87.5.
87.5. Do you guys
Yeah.
know what I'm asking you to do here? I asked you to solve Q1 from this equation. Justin, work on it.
I'm just trying to, you're dividing 35 by 0.4, you said?
You're not, you have to rearrange this. Okay, how do you solve an equation? You rearrange this, right? You leave 0.4 Q1 on one side, then the rest of stuff on the other side,
Mhm.
then you get rid of 0.4.
All she did was take 5 from 40 to make it
40 to the
35
other
and
side.
divide
Mhm.
by 0.4.
Yeah.
And then divide it by.
This is the step you have to do yourself.
The Q1, Q2, and Q3, do you have to, like, are those, they're different variables, right? So you can't subtract them.
So right now, we're just deriving an expression for Q1. So in this expression, you're gonna have Q2, Q3 there. Okay, it's not gonna be a number, it's gonna be an expression. Okay. This should not be hard. Okay, so what's the answer here? Don't now just wait for me to give
I
you.
have 87.5 minus 0.5 Q2 and minus 0.5 Q3.
Like that?
Yeah.
Yeah, that should be correct. That's what we're looking for. And what do we call this one? You guys remember? This is what we call the best response function. So this tells you that that's how the Form 1 should behave. Okay, and this Q2, Q3, remember we put a circle on the top? So we tell you that this means this is a Form 1's expectation of Form 2 and Form 3. So before the Form 1 react, they have expectation, okay? They take that expectation into consideration when they make decisions. And they're going to determine the output based on this formulation here. You guys remember that? So this is what we call best response function. Best response function for Form 1. Can you derive the best response function for Form 2 and Form 3?
It's the same, right?
It will be the same. The only thing you're going to change now here, you're going to change these two variables into the other two forms, right? Okay. Because we have a symmetric situation here. Every form has the exact same cost function. Okay. Alright, so now we know all the best response function for all the forms. Okay, so Q1 is this. So O here is 0 because that represents the firm's expectation of the other firms, right? So we have all the firms' best response functions here. Okay, what's the next step here? After we learn the best response function for all firms, what's the next step?
Set them equal to
At the equilibrium, the expectation has to be equal to what?
The extra quantity.
The actual output. So at the equilibrium, how you expect the other firms to do has to be exactly equal to the actual output by the other firms, right? So, this firm expect you guys to produce 50. At equilibrium, 50 has to be the actual output by your group. So that is a condition for the equilibrium. Remember that? Expectation has to be real at equilibrium. So those expectations will be the actual output at equilibrium. So we just eliminate those things, right? You guys follow me here?
Yes.
All right. So then we have 3 equations, 3 variables. We can solve it, right? How do we solve it? What is the shortcut to solve it? You could plug Q2 and Q3 into the first equation, and it's going to take you a long time to do it, to solve it. Or what you can do? What else you can do?
Q1 equals Q2.
Oh, sorry. What else you can do?
since they all equal the same, that isn't Q1 equal to Q2?
Louder, be confident.
Oh.
Q1 will be just equal to Q2, just equal to Q3 because this is a symmetric situation, right? All form the same, so their output at equilibrium will be exactly the same, right? Okay, so the shortcut is, we don't need the other 2 equations. We just replace Q2 and Q3 with Q1, right? Okay. Then this makes our life much simpler, right? And we can solve it. So this 0.5 will be just Q1. You move to the other side, it will be equal to what? Q1 plus 0.5 Q1 plus 0.5 Q1 will be equal to
2Q.
2Q1.
Yeah.
2Q1 is equal to 87.5 and Q1 is equal to
43.75.
right? Right, correct. 43.75. And that will be the Q2. That will be the Q3. So look at this number. It is very close to the one you played. This is the equilibrium output. I remember, which group played 50 the last round?
Was it the highest of the 3? No, we played 60.
The last round, what did you guys play?
We played, group 3 played 60. I think it was maybe group 2.
You guys played 52? Huh?
50.
You have 50, this is the 52,
We
you
played 60.
You 60. Okay, but anyway, they all much closer to this equilibrium output. If we play a couple more time, I guarantee you it's going to become more and more closer to this equilibrium output. So that's what I want to show you in the real world. That's what happens, it's not like the firms, calculates these formulas, determine, but through the playing, in the real playground, then they figuring out the other expectation, then take that into the formulation. Well, think about it. So eventually, they're gonna play the equilibrium. So all what I'm showing here is how your brain formulate the decision. You did not realize that's how you came up with decision, but this is how your brain works. Basically, actually, you guys unconsciously doing this profit maximizing calculation in your head and came up with that decision.
You got 2Q1 from adding 0.5 to both sides. So that if you add 0.5 to Q1, that makes it 1.5 Q1?
Yeah, but there's another 0.5.
Okay.
0.5 is 1, right? Then you move the other, add this 1, 2. Okay, so that's what I want to show you, how we use mathematics to understand your decisions. Okay. So any question here? So everybody understand the Kuhn oligopoly, right? Simultaneous move, and each one of your group maximize your profit, but taking the consideration of the other group decision when you make the decision. Okay. So today I'm going to introduce you the other two oligopoly models. So far I have introduced you the Sweezy oligopoly and the Kuhn oligopoly. The third oligopoly is also very interesting, okay? But it's different from Kuhn oligopoly. Okay, the third oligopoly we call it the Stackelberg oligopoly. I'm going to assign the next homework for this chapter because we're about to finish this chapter. And in addition to finish it online, all the stuff has to be written on a piece of paper and handed in. Okay? And
What about the multiple choice?
good question. Just write down the question and write down the answer. That will be fine.
Okay.
If there's no need to calculate, then you don't need the step. But for this kind of, you need the step. Okay, then do that. Because I just think this is the best way for you to learn. Stackelberg oligopoly. What's the difference between the Stackelberg oligopoly and the Kuhn oligopoly? Okay, Kuhn oligopoly is a simultaneous move, so you do not observe how the other groups behave, but the Stackelberg oligopoly is a sequential move. So there will be a leader, there will be a follower. A lot of markets are like that, right? Okay, like an iPod market, and MP3 market, and the DSL market, and also the ebook market. Okay, ebook. Who was the first company who launched the ebook reader? Amazon. They launched the Kindle, right? And that was the only ebook reader. Then later on, who else? Barnes Noble. Came up with Nook. Okay, so you see a lot of this kind of behavior. Usually, the leader, the person who, initiate the move, has a bigger market share. It's a bigger company, okay, because they have a lot of money, they're willing to test out the market. And the follower usually want to see and watch whether there's a profit margin, in that market before they jump in, okay. So that's kind of relationship between the leader and the follower. So usually the leader has more market share than the follower. And knowing this kind of, interaction between the leader and the follower, and this Stackelberg oligopoly will help you to understand how the leader take into the consideration of the followers' decision before they make the move. So before the Amazon launched the Kindle, they know there will be a follower. So their pricing decision, their output decision already take that into consideration, just like playing the chess. The chess game is stackable oligopoly because it's a sequential move, right? One person makes the move, then the other person makes the next move. Okay, so that's what the stackable oligopoly formulate, a sequential move. Okay. And we're gonna start with a very simple framework, just one leader and one follower. Okay, two companies. Okay, so we have a leader and the company, and we have a follower company. And I will just use L to represent the leader company and use F to represent the follower company. And we also need the same amount of information as we need in the Kuhn oligopoly, which is we need the market information, the demand. Okay, also we need the cost information. Okay. So let's suppose our demand is this. The market price, it still depends on the total output from both firms. The market price, it determines, okay. And the cost information I'm gonna give you is this. What's the difference of this example from the example I gave to you before?
The cost of different.
Two different cost function.
Oh,
Right? Okay, so this is not a symmetric case anymore, okay? Even this is a symmetric, we cannot use the methodology we used before because it is leader-follower situation. We know the leader's decision is going to be different from the follower's decision. So how do we approach this problem? So basically there's two stages. The first stage, leaders move, then the follower watch, the follower observe the output chosen by the leader, then make the move afterwards. Okay, so there's stage 1 and there's stage 2. So stage 1, the leader decides QL. Let's just say this is let's just say QL, okay? Just to be consistent with. Okay. And stage 2, the follower observes QL, then decides QF. Give you a second. How do we approach this problem? You have all the concept you know. You have all the concepts required to solve this problem by yourself right now.
First, we have to find out a QL first.
We have to find
That's good thinking. Good thinking. Where do we start with?
QL plus QF equal Q,
That's right.
and then we have to find out QL, and then because QF is decided by QL, so
Exactly. So QF is this QF depends on QF, right? But when the QL makes a decision, when the L makes a decision, they know the QF is going to determine the QL. So they're going to take that into consideration. I'm going to repeat what I said there, okay? Xian just said, this QF is going to depend on QL, for sure, right? Okay, that dependence is also known to the leader L, right? So leader L knows this follower is going to, is going to have a decision based on his own output. So the leader going to take that dependence into consideration when they make the decision.
So he's gonna QL is gonna maximize profit based off of QF, like where QF can maximize profits too.
Which one is going to maximize profit? Or both?
QL.
can I say that like QL is going to pretend all the QEs, it's including QF already. So QL is going to take Q, the total Q, as their decision making.
So does L assume that F is gonna assume that? L is
Exactly,
in there?
exactly. The F is going to depend on that. L is going to depend on this, depend on that.
Right.
So how do we formulate mathematically?
QL equals.
So which formula is going to maximize profit? Oh, both of them going to maximize profit. Both. Okay. And also, you're going to say something.
Does QL have a competitive advantage?
QL, the only advantage is leader.
Okay.
So how do we? So both we all agree both of them are going to maximize profit, right? So if both of them are going to maximize profit, then both of them have to follow what?
MR equals MC.
But there is two decisions, two stages, right? You have to start with one, then do the other one. Which stage are you going to start first?
QL.
Okay, remember what I said there. F is going to determine F is this going to depend on this QL, and QL this decision is going to depend on the QF, which is depend on QL.
QF.
You start with
QL.
QF.
Do you agree with them? They said QF. Start with this. How many of you agree with them?
I agree.
Do you agree? If you agree, raise your hand.
What's the question?
Are you the one always ask me the second time? What's the question? Okay, the question is which decision we should target, we should approach first.
QL.
QF?
QL.
QF? QF?
Yeah.
What about you
QL,
guys?
because QL's already factored in QL, so.
Very good. I'm so happy you said yes, we start from here. Okay. Why we start from here? I think you already understand intuitively why we start from here, but mathematically is this. Because when we reach the second stage, this information is known, right? So we can, when we solve this stage of decision making, we can assume this is a constant number because this is already known. So we only have one unknown information in this stage of decision. But if we start with this stage, we not only have to solve this unknown, we have another unknown, right? Okay. So we call this is backward induction. I remember I mentioned this before, right? Backward induction. Backward induction methodology. So what tells backward induction tells this: when you have a sequence of decision making, does not matter it's 2 stage, 4 stage, or even 100 stages, which we're going to actually have a game later on talk about. What if it's 100 stages? 100 stages. How are we going to approach the problem? There's 100 stage of decision. We always start from the last stage, because when you reach last stage, you have the least amount of unknown information, as easiest to tackle. And after you finish the last stage decision, then you go back to the next stage. Then the very next stage becomes the last stage again. So you kind of unravel like that, peel the onions like that. Okay, so this is what we call backward induction. But intuitively you understand why we start from here, right? Okay, so
Where do we start? QF?
Yeah.
Okay.
said that's from the last stage. Okay, backward induction. Okay, so then we start from this. Okay, marginal revenue equal to marginal cost for the follower. Okay. What is the marginal cost for the follower? Tell me right away. I want to ask you. The marginal cost for the follower. Yeah, I'm asking you. Okay, do I have cost function for both guys?
Mhm.
What is the marginal cost for the follower? This is the total cost function for the follower. What is the marginal cost function for the? What's the marginal cost for the follower? You want help here?
Me?
Mhm.
Sorry.
How do you find it? How do we find this three? You take the derivative of this with respect to QF. Okay? So if this one is 3QF squared, again, you have to take the derivative. Okay, so that's how we get marginal cost. We take the derivative of this with respect to the variable. Okay? So we know this is 3. How about this part? Marginal revenue for the follower. How do we do that?
Same way,
Same
right?
way, yeah.
Good. Same way, exact same way. Okay, it's total revenue for the follower, which is equal to
50Q minus.
will be P multiply what? Q. We've been doing this many times. You still hesitant about this?
No, it's P times Q. It's 50 minus Q times.
P multiply what?
Q.
Q what?
F.
Okay.
Minus
3QF.
QF, yeah.
And the P here, we have to replace that with
59.
50 minus Q F minus
QL.
QL. You guys follow me here?
Mhm.
Everybody? Are you following me, Justin?
Yeah, up to the you gotta plug 50 minus Q in for the P, right?
Okay, QF. This expression here is just P because this is just equal to 50 minus QF minus QL, right? Yes?
Why'd you do that?
Why do I do that?
Yeah.
Because I don't want Q there, I want to have QF variable and QL variable because this is the two variable we're gonna solve.
Yeah.
Are you with me, Chase?
Yeah.
Okay.
Cool. Yeah. Close.
Because this part is technical, so I want you to follow me closely.
I'm with it.
Okay, so now we have that, we open the bracket. QL, QF minus 3QF. So let's see what are the common terms. QF is here, QF is right here, so 50 minus 3 would be 47 QF minus QF squared minus QL QF. Okay?
Mhm.
What next?
Derivative.
Take the derivative, good. Okay, what is the derivative of this with respect to QF?
It'd be 47 minus QL.
2QF.
Minus two,
Minus
or,
QF.
minus 2 QL.
Minus 2QF, then minus QL. Everybody agrees?
Yeah.
Okay, then what's the next step?
And more F equal is
Two.
3.
That has to be equal to marginal cost, right? Marginal revenue has to equal to marginal cost is equal to 3. Okay, good. Okay. And this is simple enough, and I want to solve QF right now. What is QF equal to?
22 minus QL.
is 22 minus
QL over 2.
Did you get that? Did everyone get that? You following me here? Okay. How are you? Following? Are you following me? Okay, solve it yourself. Okay. Okay, after we found that QF equal to 22 minus QL divided by 2, what do we do next? So we know this is the Fuller's decision, right? This is what we call the best response function for the Fuller. So Fuller, once they see the QL, they're going to plug into this expression. Then QF, the Fullers know what to do, right? If QL is 20, and QF is going to be 22 minus 10, which is 12. Right? Okay, so far we have solved the decision for the Fuller, given the information from the leader, right? So what do we do next?
Now you have to determine QL.
Now we have to figure out the decision for the leader. Okay, now what we're going to do for the leader? Are we going to follow the exact same thing?
No,
So
because it's
maybe
not
possible.
the same.
It's not simultaneous move, right? If it's a simultaneous move, we're going to do the exact same thing as the forward, right? But this is not a simultaneous move. So the leader's decision, leader's approach to solve the leader is going to do somewhat different.
So now we do like marginal revenue L equals marginal cost L.
Yeah.
Yep, okay.
Okay.
Alright.
You have a question, Patrick?
Never mind. I was gonna say, do you substitute that one into QL for them to find out?
You want to find out? Yep. Yes, that's what we're going to do straight.
So QL is always gonna produce more than QF, right?
QL is, yeah, at equilibrium, it should be more. Alright, so let's do the, so I'm going to erase this part here. Okay, I can just be a little bit lazy here. Okay, so now the L, I'm going to ask him again. What is the marginal cost for the leader? Yeah. What's the marginal cost for the leader? Leader's total cost function is right here. What's the marginal cost for the leader?
Most.
Yeah, louder. Two. Yeah. Okay, so now we have to have leader's total revenue. And here will be QL. Right? Okay. So what we're going to change here is here will be L. Here will be 2 QL. Right? Okay, so I'm gonna stop right here. What is the next step here?
Drop the brackets.
Open the bracket, just like what we did before.
Combine the like terms.
Okay.
You plug QF into the function and solve for QL.
Did you guys hear what he said?
Yeah.
Do you agree with what he said? Yes.
Since we know QL.
What's that?
With it.
Okay. So what he said is, now you're going to replace this QF with this.
Oh yeah.
It makes sense, right? Because when L is making this decision, they know QS is going to follow this formulation. So they're going to take that decision into consideration. Okay, so 50 go to minus 22 plus QL divided by 2 minus QL and QL minus 2QL. So now, how many variables do we have? We just have one. So we're going to solve the exact value for QL now. It's no longer expression, it's going to be a number. So
Why?
straighten this up. Straighten this up.
Why is it 22 plus QL instead of minus?
There's a minus sign in front of QF, right?
Oh,
So when you put the minus sign here, you have to put the minus sign here, you have to put the minus sign in front of the minus sign, which will. Okay, so why don't you go ahead, simplify this, and tell me what you get.
No, it's a Samsung tablet. Yeah, I love it. It's great.
But is it going to change into like the type of letters, or it's just all?
Yeah, you can type or write it.
But it's going to record like that.
Yeah.
Okay.
Mhm.
Justin, any work on it?
Yeah, I'm not really sure what to do next.
Well, you
Or
just
if I do.
simplify that, you know.
Or if I even have it right.
I got 24 minus Q. No, I'm not sure if that's right. Like as the final.
24.
Yeah.
I mean, eventually you're going to have the QL squared, a term on the QL squared, and also a term on the QL, right?
Right.
Yeah. What are the parameters in front of QL squared? While you're working on this, I want to ask you a question to think of. How do we compare the outcome of this Stackelberg oligopoly with Kuhn oligopoly? Let's say I put exactly two forms in the oligopoly setting, and we solve Q. How this Q is going to be different from the oligopoly setting and the profit?
You mean a
Kuhn oligopoly.
They're equal, right?
Yeah.
In Kuhn oligopoly, in this case, would not be equal because we have asymmetric forms, would not be the same.
And in Kuhn, Q1 equal Q2. Yeah, that equivalent.
Okay. If we put this setting in a Kuhn setup, QL, not QL, it would be Q1, Q2. Q1 and Q2 would not be the same. Why? Because the cost information is different. but what I want you to compare is outcome from the Kuno setup with outcome from the Stackelberger outcome. What will be your guess?
On the answer?
Yeah.
26 QL minus 1.5 QL squared.
Okay, I asked different question, but that's
Oh,
what you
just kidding
it's
then.
okay. It's okay.
Just kidding then.
My question is, I want to compare the outcome from Kuno setup with the outcome from Stackelberg outcome. So we have now solved the output here, but I want you to start thinking about, if we say, I'm going to put this leader follower into a Kuno setting and solve this Q for each form, is this Q1, is this, the leader's output going to be higher or lower in the Kuno setting?
Lower in the.
It's gonna be closer to even.
Will be lower or higher than the Stackelberger setting? The Stackelberger, we're going to solve output for leader, right?
Maybe.
I think the Kurma will be lower.
I think.
In the Kuno setup, the output for the leader should be lower. How about for the follower?
Higher.
Follower has to be higher. We can check that later, okay? Okay, so what is this? You guys solved it?
Yeah, she got
What is it? 20?
26 QL minus
1/2.
1/2?
Mhm.
QL squared? Okay. So now we solve marginal revenue for the leader. Marginal revenue for the leader would be what? I'm going to. You have a question?
The final answer?
The final answer for the total revenue.
Yeah.
You get that, Sim? No?
No.
Check the mess again. Somebody has question? Okay, we take the derivative of this with respect to QL.
So that'd be 26
No,
minus.
I want to ask him.
I have a quick question though.
Sure.
Is it 1/2 or 1 and 1/2 for the Q squared?
What do you mean?
Because I got 1 and 1/2, not half.
1.5.
Yeah,
You got
that's what I
1.
got.
Okay, so what?
not the same.
I have 1/2.
1.5. Then I change to 1.5. If you agree. Okay.
You have the same thing.
I have. Okay, well,
You
you
have-
need to do it because everybody.
All right, I can do it. Let me do it. Okay.
Seven,
Just
seven.
squared, right? Okay, where are the square terms? This is half multiply 1. This will be, right? Okay, one of the square term come from this multiply that, right?
Mhm.
So this, the parameter in front of this QL squared is half. Great?
Yeah.
Okay, and the second QL squared come from this, the product of this, and that is minus 1. Half minus 1 is equal to
Minus half.
minus half, so it should be minus half. I'm gonna change it back.
Okay.
So here is 28 minus 2, yeah, now it's correct. Okay, marginal revenue here for the leader. Can we find mother? No, I want to ask you. Okay, marginal revenue derivative, it's old stuff. Okay, how do we find derivative of this with respect to QL?
26 minus QL.
This term, take the derivative with respect to QL is equal to 26. And the next term, take the derivative with respect to QL is equal to Chase. Yeah.
Not that way, couldn't go that way. Be 1/2 be 2.25.
0.5, this 2 is going to come down, right?
It's like a 2.5. Is that 1.5 or 2.5?
This is 0.5.
0.5. So that would be
0.5 multiply, you have to multiply this
where
2.
is 0.25?
0.5 multiply 2.
0.1.
You know, I really want to destroy calculator. You have to use calculator to multiply 0.25 multiply 2. Okay. So that is just 1, right? And then what is the power for the QL?
2. 1.
How do you get 1? This old power minus 1. Okay, let me tell you how do we do it, okay? So whenever you take the derivative, something like that, the parameter 0.5, have to multiply this power here too. Okay? Then we're going to give a new power to QL. The new power is this old power minus 1. Okay, next derivative I'm going to answer again. Okay?
She just took the derivative.
So we have 26 minus, this is 1, and we have Q, right?
She's refreshing it from the derivative.
Okay.
Yeah, I don't think you have a problem with that.
No.
Okay.
Yeah, I'm just looking.
Okay, so that's very straightforward, marginal revenue, and then we set this equal to what? Which is 2. Set this equal to marginal cost for the leader. So what is the leader's output? Okay, once we find the leader's output, how do we find the follower's output? Plug it back, right? Okay. So what is a follower's output? Let's calculate it. QL divided by 2 will be 12.
Wait, I'm sorry, what is that? QL equals to what? 2K?
What QL is?
Oh, that's a 4.
I'm sorry.
Okay.
Yeah, that's what
I
my
was
fault.
just like,
I know my handwriting sometimes is.
Okay.
Yeah, if you cannot see it, ask me, just like Jonathan does, you know. And this is 24. 24 divided by 2 will be 12, right? 22 minus 12. Okay. So that gives, it shows you the leader's output is definitely much bigger than the follower's output. Okay. So what about the price in this market?
We use the leader's output.
How do we find the price?
Plug it
50 minus.
Plug it in.
Yeah.
Where is
Right to the right.
It's right here. Right? QL plus QF equal to 34. The price is 16.
Okay. How about that?
You know, once you understand the concept, it's not that hard. You just follow it step by step. And then can you find the profit?
Yeah.
Yes.
Yeah.
You have the profit expression there, you just plug everything into it, right? It's a little bit tedious, but it's not difficult actually. It's not difficult but tedious. Huh? But if you understand the concept, then you find it fun. It's a fun. Fun. I find it fun. I do it every day.
So the marginal revenue for F is 10? Because we found QL. Okay, alright.
Plug this back into here.
Okay.
Okay.
Awesome.
So in the book problem, that's what they ask you to do. They gave you a demand, they give you a cost function, they ask you what is QL, what is QF, and they ask you what is the profit for L and F. So you have to plug back into here. Okay. So I do want to, let's calculate the profit because I want to see the number here. Okay. Because if I don't do it here, some of you may not feel comfortable to do it at home. Okay. So let's find the leader's profit first. So we have found the price, which is equal to 50 minus
16. Oh,
34, which is 16, right?
Mm-hmm.
Okay, so that price is 16 already. It's there. Somebody is never taking notes. If you remember all this stuff, that's fine. If you don't, then okay, you know what I'm saying. Okay, so the price is equal to 16, and QL is equal to 24 minus 2 multiply 24. Go ahead, calculate this profit for me. You have calculator. Calculator is useful sometimes, but sometimes just take some of your ability away. When I was in elementary school, middle school, we did not have calculators. I have calculated in my head all the time. I only get calculated when I reach college. But that really, the math really stick in my head because I have to use my head to do it.
344.
336.
Huh?
I got 336.
336?
Yeah.
336? 336, okay. Let's have a calculate profit for the follower, which is P multiply QF minus 3 QF. This is 16 multiply QF is equal to 10. 3 multiply 10. That's easy.
That's 130. Yeah.
130. Okay.
I was typing in my calculator. I was like, wait a second.
Good. All right. Why do I want to do this? Because eventually I want you to compare this outcome. So write down here on the side, Stackelberger oligopoly, QL is equal to 24, QF is equal to 10. There's something I did. I can't believe it. Somebody did not catch me made a mistake here.
What?
I made a mistake here in this calculation.
Mathematical mistake.
It's not a mathematical mistake, it's a formulation mistake earlier. Nobody caught me on that.
Wait, earlier or right now?
Earlier.
Oh wow. Wait.
I saw you guys were with me. Close.
What do we miss?
How did I derive the marginal revenue? That's what I used. Is it correct?
Just using
The regular one.
This is the profit function. This is now total revenue. The total revenue is just equal to what?
P times Q.
Oh wow.
You see, if anyone caught that mistake, they will get extra credit.
Oh,
None of you got that mistake.
I just didn't want to stop you on a roll.
So I have to do it. Okay, but that's really good lesson for us. Do not make that mistake. Okay, this is the profit function, and it's not the total revenue.
oh my god. We have to redo it all.
Yeah, we have to redo it all together. But I think you can do it yourself. Why don't you start doing it yourself? You see? That's what happens if you're not following me closely. So all this stuff is wrong. All this stuff is wrong.
We don't have time. We have money.
Alright, so I gotta.
Redo everything together. But you know the approach,
Yeah.
Yeah.
so why don't you do it yourself this time?
Oh my goodness.
Don't say you're going to do it for the homework, you do it for the exam.
Yeah.
Okay, so why don't you do it? So I have 10 minutes, I'm pretty sure you can finish within 10 minutes.
Sweet.
Okay, so you guys understand how do we do it? So go ahead, do it. So everybody know what I'm talking about?
I just know you erased everything.
Exactly, because there was a mistake when we derived the marginal revenue. The expression we used is this.
profit.
This is not total revenue expression. This is profit expression.
No, that's fine.
You see? That's what we use to find the total revenue, but it's not total revenue. This is a profit function. The total revenue is just
Q times Q.
okay. So
So really, we just have to not.
Yeah.
it's not that complicated. Yeah.
Okay. So I just
You see, there's a practice. Just go ahead, do it.
Yes, ma'am.
Think about this really fun drive while you're doing it. Start with the follower, then do the leader. No, sir. Go ahead, keep going. Yeah, yeah.
Well, that's just 16 times
Here is what happens.
That's after the fact. We don't know all that yet. We're all the way back.
It just help you to
So,
have
only thing changes is that comes off. That comes off. So that's.
So that's all. Oh, that's okay.
Good, good.
Awesome.
Going, keep
Okay.
going.
Cool.
Once you practice a couple times, it's piece of cake for you. Trust me.
Can I use my phone as a calculator?
Oh, sure. It's not exam. Of course you can use anything. You should be able to do majority of the homework after today's class. So I'm gonna sign it and it's going to be due, the graded one due in 1 week. Okay, so turn it on Tuesday. Okay, next week.
So it's gotta be online and
And
in class.
And ready.
Sweet.
Check. So this is your total revenue for 4, right? And find margin ready for orientation derivative this with respect to where's that? Let's try that. Right, P multiplied because you calculate
what'd you get for that? No. Oh, MR.
Just all the way back.
Yeah, you have to do it.
You just, you have to divide by 2. But this right here, I'm gonna know the number. It's not positive. So it's something. It's starting. Okay.
But we need to solve QF first. We need to start with the follower first. Okay. You start with the follower first. You solve the best response function for the follower first. What you got here? Okay, why some of you? We did not do the follower.
I thought
You did it? Okay. Let's see. Oh, it's here?
Yeah.
Let's see. 15 minus 29 minus. That's good.
Yeah, I take this.
No, hold on. Yeah. Then that has to be equal to 3.
Equal to 3.
Yeah, yeah. Then you solve QL from here. Okay? Okay, how about you? Got it? How about you, Robert? Okay, where's follower? Where's follower? Good. So you got this? Good. QF is equal to, but so far it's
I'm not sure.
the mass is your weak point, but you actually has so X on the side, 7. So
This is simple.
I put this on the outside. 15 minus
Yeah. Pretty much. It's close to what I have
put this here, and put this here. Okay. Now 47 minus QL equals QF.
I started from
See?
right here.
QF is equal to
Instead of like adding
47 divided by 2, which is
you just
23.5 minus
do P times Q. So this is P and this is Q. Then you go through that.
You already got this.
Yeah.
Good. Very good. So then you, yes, you do it. Yeah, keep doing. Yeah, you just need to plug this in here, right?
I have no clue what's going on anymore because everything was
How about you?
messed up.
Where'd you get the Well, how that anything to do with first still now?
And then you set one cost.
All right. Okay. So guys. Okay. So I think that most of you got quite far. Okay. So the first, you're not gonna start with leader, right? You're gonna start with the follower. Okay. Okay. I'm going to just spend a minute here when we continue. So we know the follower is 3 here. Follower's total revenue is equal to P multiply QF, right? P is equal to that. So it's 50 minus QF minus QL multiply QF. Okay, then you open the bracket. Okay, after get total revenue for folder, you have to derive the derivative, which is equal to 50 minus 2QF minus QL.
Yep.
And that is marginal revenue for folder. You set this equal to 3.
Yep.
Right?
So it's
Then you solve QF.
Yep.
Which is eventually is going to be 23.5 minus 0.5 Q.
That's correct.
So I'm going to stop here.
No, can you please keep going?
You got that?
Yeah, no, I'm the last part. I'm still getting negative even after you put the plus.
No, you got this part. I saw that.
I know. Like the next part, you said you were gonna stop.
Yeah.
I want you to keep going with the problem.
Because I run
I'll
out of time.
stay.
You stay? Okay, so I'll do it for you. Okay, but the rest of the class, you can go. We're going to continue this problem. Yeah.
We're gonna continue.
Huh?
We are gonna continue.
She wants me to continue, so I'm going to continue. But it's if you want to stay,
I'm just getting mad. I'm still getting negative.
It's
getting under my skin.
Okay, so I'm going to keep going. Okay, if you want to stay, you can stay. All right. So now, after I get this QF, then I go back to the leaders problem. And for the leaders problem, this is, we still have to find the total revenue for the leader, which is this. And this is equal to 50 minus QL minus QF multiplied QL. Okay? And this is equal to, now we're going to plug this back into here, right? Okay, plug this best response function right into here for the leader. So we have 50
No, these are the exact same. Minus QL.
minus QL minus 23.5, but plus 0.5 QL multiply QL. Okay? That's what you have? Okay. Now let's simplify this. What we have here is 50 minus 23.5, which is equal to 26.5. We have a minus QL, then we have a plus half QL. So putting these two together, we should have a minus half. Then multiply QL. Which part do you?
I know that's exactly what I got, but I want now just keep going.
To keep going.
Yeah.
Okay. All right. All right. So this equal to 26.5 QL minus 0.5 QL squared. Right? Okay. So this is our total revenue for leader.
I got it.
Okay, after we get total revenue for the leader, we take the derivative of that, will be 26.5. Here will be just QL. And that has to be equal to marginal cost for the leader, which is 2. So QL will be equal to 24.5.
I know where I messed up.
Okay, good.
When I took the derivative, I didn't times the 2, the squared by
I see.
0.5.
Yeah.
I just kept the 0.5.
We'll do more on Thursday.
Oh, I have a question about the final. Is
Okay.
that being accumulated or?
It's not. It's not. It just covers them after the second
That's not the original QF.
You said
You have our test?
Huh?
You said you have
Yeah, I have the test. If you want to pick it up, you can come here.